Today we are going to see about the practical implementation of indexing. In your indexing subsystem, there are various tasks that have to be done in prior to storing the information, storing the term, all the terms with the associate document IDs. So when you're going to have an indexing subsystem, given a set of documents or the document corpus, we are going to undergo various stages. Finally, we are going to index a term along with their weightage factor. Not only the weightage factor, we are going to have the document ID. So when each document has been assigned an unique document ID. With this document ID only, we will be retrieving the end results. So the various tasks that are accompanied for the indexing process is tokenization, stopword removal, stemming and normalization, term weighting. So this task we have been seen in text processing itself. The same process we are going to have as a continuity for a retrieval system. So tokenization we are clear with, we are identifying the special characters have to be removed. Okay, identifying the any blank spaces have to be removed. So we are identifying each and every word as a tokens. Then we are going for the stopword removal, identifying the noun. Okay, removal of frequently occurring the words. Stemming, we are identifying the root word, or if it is going to be any numerical characters, we are going to normalize it. Numerical values, we are going to normalize it, but normalization won't be a major factor here. We are just going to have a stemming part. So normalization for a character in the sense that we are just going to add few more characters to end up with. For example, if we are going to have normalization, so in order to have the normal, so TION will be removed. Normalize it will be there. It have to be redefined as normalize. Okay, so that is your normalization in your words. So this will be performed. Then we are going to have the term frequency calculation. So for a term, we are going to index a term along with the term frequency with their document ID. So for a document ID, we have set of words for this particular document ID along with their term frequency as the schema. So each and every um, enterprise has their own way of indexing structure, so that for retrieval they will be equipping their fastest way of retrieving the information. Now we are going to see how this indexing can able to be implemented in Python. So prior to the process, we are just going to incorporate all the necessary libraries to the coding. So for this we have been used the whoosh, so whoosh schema. Not only whoosh, we can able to adopt any other indexing techniques for your retrieval process. For if you are using your Ubuntu, we can able to use your Lucene indexing or your Solar. So as of Windows, I'm making use of whoosh. Okay, so we are going to have creating an OpenDIR to create the indexing structure, uh, which have been taken up from the whoosh.index, and we are just going to accompany the schema and text with ID. This information have been taken up from the whoosh.fields, and we are going to utilize the query processor to a query parser to processing the query. So this query processor have been imported, which have been taken up from the whoosh.q parser, and for identifying the directory we are going to use OS, and to tokenize the word we are going to use the regular expression. So prior to the coding of instructions, we have just defined the stopwords. We have just listed out what are the stopwords are, and we have just defined a simple stemming. So as of simple stemming, I have just illustrated only 5 of the suffixes. You can able to have more number of suffixes, or you can, instead of this simple stem, you can able to adopt your NLTK based predefined stemmer method, potostemmer method, so that it accompanies the similar set of tasks. So here I have just defined few suffixes, and with these few suffixes, if the word is ended with this suffix, we are just going to remove that word and return the specific word. This is the process has been carried out in a simple stemming. And the pre-process of text, we are just going to identify the tokens and converting the capitalized word into lowercase. So here we are just going to use your regular expression and using the find all method to identify all the set of pattern that exists, which is going to identify the set of word. And after identifying the word, we are just going to convert it to a lowercase. So this returns specific set of words. For those words, we are just going to find out whether it is those words is not in words, stop words, which been written to these words, and we are just going to identify or process the stemming process to it to the word, applying the simple stem which have been defined in this code. So passing the word to the simple stem, which can able to apply and apply the stemming process, and the information has been stored in the pre-processed words. So the pre-processed words has been written to the pre-processed text. So here in your schema definition, this is our basic lines of code when you're going to have any indexing structure to be specified to your searching process. So here we are just defining a schema. That schema holds a title, okay, in which the title has been stored in the form of text, where text is it can able to have numerics or characters. Any alphanumeric characters also it can able to be supported. So we are generally presenting into as text. So it can able to be stored in the form of strings. So when I'm going to make use of store equal to true, I can able to retrieve it using the title. So the next field which I have been given is the content, the actual information of the document. The actual information of the document also have to be saved in the index. For few of the application, this actual information is not a mere to be stored. So here stored is equal to false, which means that the content will be taken under process, but it has not been stored to the indexing process. So we cannot able to retrieve the information based on the content. Similarly, for a doc ID, we are storing it in terms of the ID, which means that it is going to be unique. Here we have been specifying the unique is equal to true and stored is equal to true. Based on the document ID also, we can able to retrieve the set of information. And one more term we have been added up to the indexing part is the term frequency, where this is going to be added up in terms of a strings, and this stored is equal to true. We can able to retrieve the term frequency with from the indexing part. So this is the schema which we have been defined for our retrieval process. So prior to the process, we are just going to have the index directory. We are just going to create or open our index directory. For that, we have been specified the path and checking whether the index directory path exists or not. If not, we are just going to make a directory of this. Okay, and once we have been made the directory, we are just going to open the particular directory. If the directory is not been found, then we are just going to create a new directory based on the path which has been given and based on the schema which has been defined it. Okay, so we have just created an index directory to which the indexing file to be saved. Okay, so whatever the information which have been stored will be stored in the form of an index. Next, we are going to start the process in terms of the document corpus. So for that document corpus, we are just defining the directory path. So if the directory path doesn't exist, we are supposed to make the directory path. Okay, if not of this corpus, we are just going to make the directory for that particular corpus. So with index.writer as writer, I think we are just going to identify the list directory. We are going to take all the files that are exist in the path, the, the corpus directory, and once we have been listing out all the files, we are going to check whether it is going to be ended up with .txt file. If the file name is ends up with .txt file, we are just going to process it. Okay, so opening the file with a specific path, another file name in the read mode, and we are just going to read it in the encoding format of ETF8 format. Okay, reading the content of the file using read method. Okay, file.read method to have the content, and we are going to process the text. So for processing the text, we are going to use the function preprocess underscore text, that particular content. Okay, passing the content, and the function moves on to invoking the function which has been defined here. So passing the word, and we are just going to have the tokenization and the stop word removal. Not only stop word removal, we are going to have the stemming of the words, and it return the processed word. So this have been taken up over here. So the processed content will be there. So we are going to calculate the how much frequency that it exists to the document. So top frequency initially which has been null, and for the word in the process content, so process content is a word. So this have been taken up. So this is for the entire file which has been taken up. For this entire file, we are just going to apply it. So process content will be the group of set of words. For this set of words, we are going to take it one by one, identifying whether the word, get the word. If the word is not there, we are just going to have an initial count to it. If not, if it already is there, as more number of times the word has been occurred. So by that time, we are just going to utilize all those countage factor to it, add all those countage factor and storing it as the term frequency for that particular word. So we are just going to process each and every word, identifying the frequencies and storing it in the form of an array. So now this information have to be taken up to the indexing schema. So for writing the index structure, writer.add_document. Add document is the method. We are going to enclose it for the writing the index structure to the schema. Writer.add_document. So we are writing the title, which is nothing but the file name, and we are just going to have the content information, which is nothing but the concatenation of all the processed content, the dot join of process content. So similar to the information which have been related to the document. And the next one is your doc id, so which is also related to the file name here. And the fourth field which you have been written is the string of your term frequency. Here we have been normally add all those informations as numericals, but in a schema part we have been specified it as text, so it should be converted to string format. So we have been utilized as str. So we have returned the indexing information to the index schema. So as a information to the user, we are informing that the indexing part has been complete. So how we can able to check it? So through your query, you can able to check whether the information is been there in the index part or not. We are going to analyze it. So for that, we are going to have a search index function which has been defined, passing the query text, pre-process this query text using calling the preprocess underscore text. So the same set of tokenization, stopword remover as well as stemming will be carried out in your query text, and we're just going to have this index.searcher. So index.searcher, where index is where you have been written the content to it. So to that we are just going to have the searcher method to be called up, invoked. So for that we are going to have the query parser, query parsing have to be there for the content information. Okay, given the content and the schema structure, we are just going to parse it. So parse based on the query which has been segregated or tokenized equally. So this is my query which has been actual query that have to be searched in the given index. Okay, so we have just defined the searcher. Okay, that is nothing but the index.searcher method which has been invoked, and we have been mentioned about the query parser, which is nothing but the content information have to be there, and we have been related to the index schema and parsing the given query text. We have just combined all those queries. So this is going to be list of query words. Okay, this list of query words has been given up to the search process, search method. Okay, for the searcher, using the search method, the query has been passed to the search method and it produces a set of results. Okay, so the set of results should be an unique one. Okay, for this unique set, we are just going to identify from the results. It produces n number of results. For those results, we are just going to identify what is the doc ID. Okay, and if the results is already there, we are not going to process it. We are just going to have the unique doc result, end results for the user. So if not in unique result, we are going to process the doc ID. So adding this doc ID to the unique results and searching for the result and evaluation of your term frequency. Evaluation here we have been stored it in the form of a string, but it have to be converted into numeric. So we are making use of the evaluation process. So converting the string back to the dictionary format. Then we are accompanying the summation process, summing of all the words that have been taken up related to the given query words. So initially we have process for a single query. If it is a query phrase, we are just going to add all the words under that query phrase, and we are just going to return the title and the document ID, and following that we are going to have the query occurrence of term that exists in the documents. Okay, so this we are going to have specified in the search index function. Okay, this we have been defined it. So here more or less the title and the doc ID is going to be one and the same. Okay, so now we are just going to give a query and check it for the function, whether it has been searching the appropriate returning back the appropriate result or not. So for that, given query as user query, search that particular query in the search index. So when this function has been invoked, it automatically goes in for the function call. Function has been invoked, this function has been taken part. Okay, and on running upon this code, and able to have the indexing process has been completed. We are just storing the terms along with the set of information. Okay, and we can able to check it in terms of the title, that is your doc ID. Here the doc ID is and the title is one and the same, and we are just printing out how much time that the term occurs in this document. So here we have been added up as title, content, doc ID and term frequency. Along with this, we can able to have a separate set of array information as a vocabulary of list from the document. So this vocabulary of list can ensure that these are the set of words that exist in the document. Based on this array concept, based on this vocabulary of words, we can able to search it in the query. So this is the second alternate way where we can able to use it for. Okay, so takeaways of this exercise, we have this we have defined the schema for indexing. So what are the contents to be indexed? And we are initially started off with the processing of documents. Write the whatever the information that are required to the indexing part in the form of schema. We have been written to the document. Okay, then to verify whether we have been utilized the whether the word has been indexed or not, we are checking for the index term through the searching process, and this search process returns the results by their ID and their frequency from their index. So for this set of tasks to be done, the necessary libraries for the indexing parties, we have been utilized the whoosh. So for this whoosh schema, in order to make use of the create index or OpenDIR, these are the libraries which have been imported to the code taken up from the whoosh.index. And for your fields, we are just illustrating the schema method and the textual representation, the string representation, and ID format. These fields have to be imported to be defined for your indexing structure taken up from the whoosh.fields. So these two related to the library for indexing, and for query processing, we are just taking out the uh, query processor, query parser, imported as a library method which has been taken up from the whoosh.queryparser. So here in our practical indexing, we have given an input set of documents, process it, and storing those information in a structured way, in a schematic way. Okay, so based on those information given a query, we can able to identify whether the word exists in the particular information or index or not, retrieve the appropriate ID documents, and based on the frequencies, it produces the end results. Thank you.